Hello everyone, welcome to my channel and welcome to the chemistry class. Today I will be discussing about the chapter Chemical Thermodynamics, class 11 science. Few days ago, one of my student has asked me to solve the following problem. Now the next week I will be uploading one complete video on this chapter, but today I will be solving this question. So it is written, the question is, the given figure shows a change of state A to state C by two paths ABC and AC for an ideal gas. Calculate the number one question is path along which work done is least. Then second one is internal energy at C. If the internal energy of gas at A is 10 joule, an amount of heat supplied to change its state to C through the path AC is 200 joule. Third one is amount of heat supplied to the gas to go from A to B if internal energy of gas at state B is 20 joule. So at first what we have to do, path along which work done is least, right? So in this question there are two paths, right? One is pathway. One pathway is you can see A, B and C. It is going to this direction, so ABC. And one pathway is clearly visible AC, right? So you have to calculate the work done for these two pathway. Now work done for pathway ABC will be the work done. We will break this into two parts. One is work done from A to B and another one is work done from B to C. So we have to calculate this work done for pathway ABC at first and then AC. Okay, so before solving we will list out what is given. So we will make a list by writing given, and all the information given we will be writing here. Although for the solving the first question, path along which work done is least, and second, internal energy at C we have to calculate, and if the internal energy of gas at A is 10 joule, so internal energy is represented by U. U of A is 10 joule. It is written, given, an amount of heat supplied to change its state to C through the path AC is 200 joule. Amount of heat, that is Q, to go from A to C is given 200 joule, and amount of heat supplied to the gas to go from A to B if internal energy of gas at state B, so U at state B, it is also given, which is 20 joule. Clear? These are the information given. Now again back to our problem, that is A. We have to calculate separately the work done for ABC. So work done for ABC we are separating into work done AB pathway and then work done in BC pathway. This pathway AB, this one, and then BC pathway. The two pathway we will be doing like this. Okay, so work done and AB, I am writing the formula of work done. So those who don't know the formula of work done is minus P external into delta V. This is the PV work done, pressure volume work done. Clear? So I am just only writing that P delta V plus of, again, P delta V. Now how to differentiate? Of course this is for AB pathway, so I am writing here AB and BC. Okay. Now if you observe the pathway A and B, the volume is fixed at 2 meter cube, right? So here we can say delta V is 0. If it is 0, so of course the work done will also be 0. Now we are left with work done for the pathway B and C. Pathway B, this point, what is the value of pressure? It is 15, of course, 15. And B and C, this is isobaric process, so it is of course again 15. So pressure we will be taking at 15. And what is the value of volume? The value of volume will be 6 minus 2, because at point it is 6 and this is showing 6 meter cube at C point, and at A point it is not A, B point it is showing the value 2. So it will be 6 minus 2. Okay. So the value we are getting, it is minus 15 plus 4, which is minus 60 joule for the pathway ABC. Now we have to solve the pathway for AC. For AC, again the same formula, P delta V. This time, as you can see, the pressure is changing from 5 Newton per meter square to 15 Newton per meter square, A point and C point. So we will take the average, half average of the pressure, 15 plus 5 divided by 2 into the value of delta V will be 6 minus 2 again, because at C point it is showing 6 meter cube and A point it is showing 2 meter cube. So it will be 6 minus 2. Okay. So the value will be getting half into 20 into 4. So it is minus 40 joule. So here we got the work done for the pathway ABC 60 joule, and for the work done for the pathway AC is 40 joule. So of course path along which work done is least, the answer will be ABC or AC. Of course it is AC. Clear? So first answer is AC pathway. Now second one, internal energy at C if the internal energy of gas at A is 10 joule. Internal energy at C. Okay. So we have already written U at point A is 10 joule. So now we have to calculate the internal energy at C. So we have to calculate this internal energy at C. Now what is given? Internal energy at A is 10 joule, and the amount of change of heat energy from A to C is 200 joule. So from the first law of thermodynamics, it is Q is equal to delta U minus W. This is the first law of thermodynamics. First law. Now We know the value of W. We have just derived the value of W is, for AC it is 40 joule, minus 40 joule, right? So delta U equals to Q plus W. So what is the value of Q? Q is given, which is 200 joule, right? It is 200. So 200 joule plus work done is minus 40 joule. So we left with 160 joule. What is this? The value of delta U. Now delta U, for the pathway we are calculating AC. So we can say U point C minus U point A is equal to 160 joule, because the arrow is showing us this value, right? This is the final destination and this is the initial one for the pathway AC. So U of C minus U of A, or UC equals to 160 joule plus U of A. So 160 joule plus U of A, it is given, which is 10 joule. So this is 170 joule. Clear? Now the third question, that is amount of heat supplied to the gas to go from A to B. Okay, amount of heat supplied. So we have to find out Q for the pathway A to B. A to B. You have to find out this. Again we will write Q equals to delta U minus W. Now first question, when we are solving the work done for the pathway ABC, the work done for the pathway AB was 0, right? Because the change of volume was 0. So again here we could use that information, so it becomes Q equals to delta U. Now delta U for AB will be U of B minus U of A, because the arrow is showing the final destination is B. For the pathway AB, initial one was A, so it will be U of B minus U of A. Now U of B, it is given the value of internal energy at state B, it is given 20 joule. 20 joule minus U of A is also given, right? It is 10 joule. So change of heat energy will be 10 joule. This is the answer for the third one. Okay, so I will be sharing the mail ID in the description. You will check, please check it, and if you're having any doubts you can send me, you can email me. And uh, next week I will be sharing one complete solution of some of the important questions from this chapter. Some of them will be diagram based and some of them will be um, coming from various equations. Thank you.